Hey everybody, this is Larry. This is June 4th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem. Today's problem seems to be a classic problem and queen, so I guess we're no longer doing that prefix thing. Yeah, and queen is a classic problem. Return all distinct solutions. Okay, so one thing about this one is that is it really today's problem? Okay, because yeah, it is just backtracking, right? There are all these cases, and you just have to do it because, and you can't really do better than that because literally you have to print them out. You have to like have the configurations, right? So you can't really do faster than just iterating them. I mean, obviously, there might be some optimizations that you can do to make it faster, but in that case, it's going to be backtracking. It's still going to be exponential. So let's just get started. And then the idea is just what you think it is, right? So the naive backtracking maybe just put a queen in a place and then go to the next cell. You can go and then like for example, if you have a 4x4. Right, you may first try to put a queen here and then try to put it on here and then no good, right? And then so forth, and then do a for loop like that, and here no good, right? And here something like that, right? Of course, the second optimization that you can notice here is that, well, each row is not good. And I mean, once you use a row, you can just go to the next row because, well, that row is no good. It's already occupied by a queen. And then the second thing is that you could do the same for column. And then next is you can do the same for diagonals. I feel like I did I was going to say make a comment about diagonals about we did recently, but I think I was just practicing a little bit on code forces by myself just to kind of warm up. So I don't think I have it on video. But the idea here is, and this is something that you get from practicing a lot, or maybe just a little bit. But for me, that's what I get for practicing a lot because it takes time for me to figure these things out. But the idea behind diagonal is that, and let me put up the paintbrush thing. I'm drawing, so give me a second to set that up. We have something like this, right? Nope, you don't have something like this. Huh, why is this not pasting? Am I not clicking right? There you go, that was weird. So you have something like this, and then the idea behind these behind the diagonals is that you could draw these things in many ways, but like you could have 0 index or 1 index, but let's use 0 index. So this is 0 0 0 1 0 2 0 3, right? 3 1 1 2 2 and so forth. And then the idea about labeling the diagonals is that just try to find out the common pieces, right? Well, going to this diagonal, what are the common pieces? Well, x is equal to y. In this diagonal, this will be, what is it, 1 2 2 3, right? That means that x is equal to y minus 1, and then dot dot dot, right? You can see the pattern here, and this way is the other way as well. It's going to be x is equal to y plus 1 and so forth. And then also the other pattern that you can think about, so then these are the diagonals going this way, but then obviously you also want the other diagonal going this way, right? And then you try to figure out the pattern here. Is that true? Actually, maybe I made this up, actually. Maybe I'm just wrong here. So, yeah, okay, that should be right. But just want to make sure. Right, and then the other diagonal is the same idea, and that, well, here it is going to be x is equal to y still, and then here, what is here? I think like it's like, is that true? I don't know about this one, but yeah, it's something like negative x is equal to y minus 1 or something, maybe. Oh no, this is, whoops, I remember now, sorry. this is I don't know how to phrase it, but I mean this is right actually, but right, or maybe -1, I forget. But whatever direction is, the way that I think about it, I know that I'm writing it just to kind of demonstrate the pattern, but the way that I have it is that for these diagonals, it's going to be x minus y is equal to some c, right? And the c will be the diagonal name. I just c for constant, but and then going to this direction, you can think about it as x plus y is equal to c. And this is just like an observation. You know, you're doing that. Yeah, if you're doing enough, you'll notice it. So that's the thing. And having this, what's the point, right? Having this will allow us to quickly check whether a diagonal is used the same way that you know, a quickly way to check whether a column was used. I'm gonna go to the column first, and then we'll go over how, you know, things are together. So let's get started. Yeah, and let's just say we have some recursion or try row of let's say the row, because we know we skip each one, so then now we have a row number, we have a current board maybe, and then let's say a column used, right? Columns used, yeah. And yeah, and the two ways you can do about it, one is have kind of have solutions and then aggregate it up, or you could just do it as you please. That's the way that I'm going to do it, is that with row is equal to n, then we just because technically I think in theory I would like to keep it, you know, each function call returning everything that had returning all the possible substates, but this is actually, I think, faster, and so it's a pretty much optimization, but it is for me. So then answer.append board. The reason why I have this is because it makes a copy of it and versus making a thing, because otherwise I think I see this a lot, which is that, and I get this as a comment sometimes, but what happens is that if you have, let's say b is equal to some, you know, 1 2 3, and then you do and that b and then answer that b, right? Then what happens, right? And then now b of, let's say you change the element to 5, what happens is that answer is now actually equal to 1 2 5, technically references to b. Well, answer contains bb, but when you print it out, it would actually looks like 1 2 5 1 2 5, right? Because now b is a pointer to an array. So what you want to do is actually you want to make a copy of it every time you append it, so that now they make a copy, right? So then you don't have the same thing. So this happens a lot. With my experience, I make these mistakes from time to time just because it's very easy if I don't pay attention. But when I'm paying attention, I'm usually pretty okay about that. So yeah. And then now we go yeah, so so now we try to do a column, right? For the code cell is in range n, so if columns used, then we'll just use a boolean here maybe, or we'll use a set just because it's easy to thing. So if column is not in the used, then we want to use it, right? So board of row of column is, this is actually may not be sufficient even because of what we said, but for now that's okay. Is equal to queen maybe. How do you want to work? I mean, we might have to fix something, but that's fine. We just get a general feel. So then now we try next row, row plus 1 board columns used, right? So this is just standard. You know, we change the state and then we change it back. You know, leave it better than use it, and this is remove. I don't know. All right. I know that this isn't right, just to be clear, but let me try running it real quick just so that I what is this? Oh, n, that's why. This is also why, by the way, the thing that we said about this and this is why we write this way. Because if you just write times n times n again, I guess in this case, you would have all the pointers. But yeah, and then just a new set, right? I just want to run this real quick. I know that this is wrong. We don't even return anything. I guess we could return answer a bit, but just to see, just want to see if I have any typos or something like that. And of course, we didn't really put answer. But yeah, the reason why I just have so many is because I messed up, I suppose. That's weird, actually. No, I mean, this is fine. Yeah, the reason why there's so many more than we expect is because we don't take care of diagonals. And this is intentional in just that, like, we want to talk about why do we need the diagonal optimization? I mean, well, I mean, you still have to take care of it. Otherwise, you might have a, you know, in this if statement, you could check whether, you know, you check whether, you know, given a queen in row and columns, then now you have to look at every other row and column just to see if they are at the same place or something like that, right? But if you want to do diagonals, then that makes it just easier to do it in O of 1. That's basically the idea. Yeah. And we have 2 diagonals that you probably just know visually. So then one is row minus column, and then the other is row plus column, as we kind of used. Yeah, and this should be a little bit better, though. I think I don't allocate the space correctly here. So, oh, and I don't recurse correctly here anyway. Yeah. Ideally here we have the right amount of answer, but not the correct answers. So yeah, we will see. Oh, did I? Oh. Wait, no. Huh? Did I do this incorrectly? Add, remove, row minus column. Why would this be wrong? Because this can only happen after this, right? Oh. I forgot to check. That's why. So it was just removing stuff. Yeah. Not in diagonal 1 used, and row plus column not in diagonal 2 used. So therefore, it's just removing stuff without adding. Huh, that's a silly mistake. But yeah, that's the check. And here, like I said, I'm just looking for, well, this is wrong just because I have array of strings instead, but I was looking for having the right number of answers, if you will. And it looks like that is the case. We have 2 answers, even though none of them got filled in. But yeah, so here, maybe we don't need to do all this thing, but we do need to do something like for row, for all in board. Okay, so current is equal to and then answer dot append current. And here we don't need to, I mean, you could do this as well, but we don't need it because we allocate this memory right there. So yeah, I mean, you could copy it again, but that just makes it slower. Okay, so that's pretty much it. I mean, there are only 9 cases, so that's, you know, we can brute force, and you could just saw me brute force typing it in just to see if we're right. And this looks good, so let's give it a submit. Let's give it some love, see if it's fast enough, and that's pretty much it. Yeah, much slower than last time, but 795 days. But yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Oh, I did the same thing last time. Okay. Oh, I had a better abstraction last time though. Huh. But yeah, that's pretty much it. So yeah, stay good, stay healthy, take care of mental health. I'll see you later. Go Rangers, and yeah, I'll see you later. Bye bye.